Introduction to Statistical Learning, Chapter 7, and we're on question 8 in the Applied section. So here's the question. So we are supposed to fit some nonlinear models on the AutoSet data, and we are supposed to look for evidence of nonlinear relationships in this data set. Okay, and create some informative plots to justify our answer. All right. So the first thing to notice here, obviously, is that this question is very open-ended. So we're not told, what variables we're supposed to look at, and we're only supposed to, and we're really only directed to, indicate whether or not there's evidence for nonlinear relationships. Okay, so just as a matter of probability, in fact, let me just load these up here. Just as a matter of probability, we have all of these different variables right here. And so if we took it, if we just looked at every, two variable relationship, we'd have, so we have 9 variables. We have, like 9, choose 2, 9 choose 2 possibilities for a nonlinear relationship, roughly. And so just by probability, we should guess that there's probably some nonlinearity somewhere in the data set. Now, we should also, so just aside from that argument, we should surmise that there's probably going to be nonlinear relationships. So, for example, certainly acceleration is increased with horsepower, but we should not expect, I don't know much about cars, but I would be really surprised if acceleration increased linearly with horsepower. I rather suspect that as horsepower goes up, acceleration does go up, but there is diminishing returns, right, with each additional amount of horsepower. So we should just surmise that these are probably in here with at least some variables. Also, there's something that's just a little bit off-putting about the way that the question is phrased. The question almost seems to indicate that we will derive evidence for a nonlinear relationship by fitting a these nonlinear models. Okay, but that's not really evidence, right? Because even if we fit a nonlinear model to linear data, the model will fit just fine. In the same way that if we fit a linear model to nonlinear data, we will get a fit. Okay, and so really the evidence has to come from something like comparing the linear and nonlinear models to one another to fit, right? So this could be something like cross-validation or information criteria, AIC, something like that. And here I'm just going to use AIC. The principle is we need to compare these models if we're going to see if there's evidence for a linear versus nonlinear fit. Okay, so here, you're free to look at whatever relationship, but I'm just going to use the one that seems most likely to, or that seems likely to yield a nonlinear relationship between acceleration and horsepower. So I'm just loading the auto data set here, okay? And first, let's just look at this relationship here, okay? So I would certainly tend to see a nonlinear relationship here, but if somebody were to say, I think it's linear, I could almost be argued into it being linear as well, okay? And this is why we really have to compare the model fits, okay? So the first thing I'm going to do is just fit a linear model. And like I said, I'm going to compare the models using AIC, but you're also, free to use other methods like cross-validation or whatever. So there I've done it, okay? And now I'm going to fit some splines to it, and I'm going to fit a lot of splines to this, okay? I'm going to fit one spline model for every 1 horsepower unit between the max horsepower and minimum horsepower. I'm not sure what that comes out to exactly, but it's a lot, okay? So I'll run that, and then in the end, I've packaged that all into this nice little data frame here that says how many knots we have and the AIC value for that particular knot, okay? So there we have that. So now I want to know what is the best spline model, okay? So I'm doing that here with the code. And I also want to know how many of these spline models are doing better in terms of AIC than the linear model. Okay? So I run that, and we see that the number of knots, so 3 knots, is apparently the best. If I look at this AIC value and I compare it to the AIC value of the linear model here, I see that it's, the spline is doing better, okay? And then of all of the models that we fit, it looks like we fit 184 spline models here. Roughly 11% of them are doing better than the linear fit. So the linear fit is not terrible, right? Which again, kind of, um, maybe goes part of the way to saying, why it would be easy to squint your eyes and see a linear fit here rather than a nonlinear fit. Okay. Um, so really the evidence for the linear fit being better, or I'm sorry, the nonlinear fit being better is here. It's just the AIC value. Okay. Um, Now, just because we're supposed to make some graphs, and also it's interesting to make some graphs, I'm going to take the best spline here, which had 3 knots evenly distributed across the across the range of horsepower, um, and I'm just going to call that my best spline model, and then I'm going to plot it against the data and compare that to the linear fit model. Okay, so I do that, and this is what I get. So the red, obviously, is the linear model, and then the the blue curvy one is the spline model. Um, and so when I'm given this, I'm a little bit suspicious of the AIC, or I'm a little bit suspicious of saying that the relationship is really truly nonlinear, because this spline model, because of sampling variation, I would not suspect these little humps and bumps along the way, right? I would really suspect, a much more curved, more of a less bumpy ride as I go down, right? I mean, that would just suit my, my prior beliefs about what this relationship might be. And the fact that we get kind of this bumpy stuff here, says, well, maybe 3 knots isn't the best. In fact, just on the fly here, let's do this again with just 3 knots, roughly evenly spaced here, and we'll do 6.66. I'll just mute this guy. So now we just have two knots. Okay. Okay, all that should work. Yeah, I don't know how to feel about that either, but but to my eye this might be better. So here we might want to run something closer to cross validation, or continue to investigate this relationship. But yeah, I think we'll call that good.